Welcome to the 2017 CES report by the Entertainment Technology Center at the University of Southern California, a think tank and research center within the School of Cinematic Arts. I'm Don Levy. Each January, our team of analysts, professional journalists, and researchers cover the massive trade show's conference sessions and 2.6 million square feet of exhibit space. We distill our daily coverage before and throughout the show into a comprehensive print report that is available and free at etcentric.org/CES, and this presentation, which provides more detailed analysis and commentary from the ETC team. It is my pleasure to introduce our colleague, George Gerba, who leads today's discussion.
Thanks, Don. This is George Gerba, and I'll be your ringmaster today. Let's introduce everybody around the table.
Hi, I'm Phll Lelyveld. I run the VR/AR initiative at the ETC. I'll be covering those topics.
And my name is Erick Moen. I'm a PhD fellow at USC, and I do scientific consulting, so we'll be trying to give you the scientific edge of all the things we saw at CES.
And I'm Yves Bergquist. I am the director of the Data and Analytics project here at ETC, and I'll be talking about data and artificial intelligence.
So let's get started. Here's our agenda for the event. We're going to look at CEA trends, then what we thought we were looking for as we went towards the CES, ETC trends. Then we'll look at audience experience, including everything that an audience deals with. And then we'll look at sensor development, data analysis, and implications for the industry. And then if we have some time, at the end we'll look at what was fun. Well, this year was really very interesting in that we saw the AI change engine arriving in really big force. And AR was getting better, VR is getting better, and a wider palette of new kind of content things are going to be available to us because of that. CEA's trends really focused on the way computing was going to change the world for us, and AI is beginning to move in as connections and computing affects everything about what we're doing. Transformation is also going to be important as it's a driver of compute capability. And digitizing the consumer experience is getting more and more important. We were looking for ambient experiences and examples of that actually happening in the real world. We did see it actually mentioned as an important new trend at a keynote from NVIDIA. Applications of machine learning are going to be very important, and we expect to see those. We hoped that we'd see new television interfaces, but honestly didn't see much. VR and AR and mixed reality were very important. Blended reality, as we put those two things all together, are becoming important. And we hope to see some security issues addressed, perhaps not as much actually in reality as we had hoped for. So understanding the audience experience, we're going to group everything together here: HDR, OLED, QLEDs, lasers, headphones, world building, the whole thing, and how realities are changing. At Sony, we saw a really interesting screen. It was a 65-inch OLED. And what was really curious about this one was while it was so thin, it also had transducers attached to the screen itself. So sound was actually coming out of the screen and localized. On the back, we see a stand. That stand actually is also the subwoofer. But more important, perhaps, was a modular display that we saw done at scale. In this case, it was 2K by 8K and rather spectacular. You can actually see the audience reflected in the surface here. It's OLED and it's really beautiful. About a 17-inch module was built up to make this incredible display. Seamless, absolutely seamless. Perhaps this is the future of movie screens, although at the moment, at $1.5 million for this screen, perhaps a little too expensive, but really exciting as a potential for what might be going on in that case. Here's something interesting, and perhaps a trend that we saw across all of the screens that we noticed. On the bottom screen, it's a basic LED screen. Up top is one that's been enhanced a bit with some quantum dot-like structure. Notice how real it's looking. And off to the left, the real-world diorama being shot live by a camera. Notice that those worlds are almost exactly the same. And that's one of the sort of big trends here. Screens have gotten so beautiful that actually people were paying less attention to them in many ways across many of the large screen exhibits that we saw throughout the show. Here's a rather spectacular one that was at LG. This one's impossibly thin, like that Sony screen, and so light that on the other side of the glass it's being supported by just those 4 tiny little magnets. Below it is a sound bar, and that sound bar is actually doing Atmos. That was pretty interesting, actually. But again, it garnered interest, but not the massive interest of just last year. We also saw that at many of the value providers, many of the kinds of activities that we saw earlier at the majors being done. So here we see an attempt to do an EEG-based interface. Now, honestly, it wasn't really very exciting, but it was interesting that they were pushing into that space. More importantly, they were pushing into the space of entertainment and the experience with our audience and setting expectations with our audience as energy management and home systems and Alexa-like devices were exhibited by almost everybody. Entertainment often is off in the corner in those big exhibit spaces. It's interesting to see them wanting to play with interfaces that connect directly with our audience. Here's something really interesting developing in the mobile VR space, where it's possible now to get positional data from very little investment in terms of headsets. Let's take a look at what we saw at the Zeiss booth. Phil?
Okay, so what's really interesting about this is that cell phones are taking on the characteristics of the high-priced head-mounted displays, the Oculus Rift and the HTC Vive, that sort of thing. As that technology gets built into cell phones, it's actually enlarging the market, the mass market, for that type of headset and pushing the higher-end headsets into more of a niche market. This is where the future is going to be.
And this is actually just an iPhone with a single camera doing both position and Z-axis. That's pretty amazing in terms of the compute capability that's being utilized there, and software on top of it that's actually putting together a really compelling price point in terms of having an experience that's much more complete than the current sort of mobile VR world that we're used to. Add a couple cameras to that, and the world changes once again. And here we see a projected VR image that actually adds to the room around you using the display for that high-quality image of the gaming zone. And here we see a discrete object with just a task.
Mm-hmm. And here's one of the big questions that the consumers will answer for the industry. Do you want a fully integrated technology package, like a car with this navigation system built into it, or do you want, as this one happens to be, something that you can just put on your dashboard and swap out as technology advances?
And with more and more 3D images being developed, it's curious that here we see a globe with a touchable, navigable interface that allows you to perhaps view production footage with a group around a table.
Right, and a big issue with virtual reality is how do you show it to consumers? And it's proven difficult to show with head-mounted displays in retail stores. It may be we want to go with spheres and domes.
As a demo.
As
right?
a demo,
yeah,
for demos.
That's kind of interesting.
Yes.
And of course, haptics are becoming very important. This one perhaps emerging towards the end of the year.
Mm-hmm. Yeah, we're seeing lots of haptics, lots of other sensory inputs. And we're not going to really delve into it very much, but the whole idea of what can we standardize around VR and AR is a big question. We don't want to standardize too much too quickly because that could stifle innovation, but at the same time, we're seeing sensory input dealing with tactile sensory input, but also smell, taste, and other things.
It's kind of exciting thinking about actually climbing a mountain and getting enough pressure that you think your feet are actually climbing up something like that.
Oh, absolutely.
That'll be fun.
Mm-hmm.
And this is really interesting. Finally, the AR glasses are getting a little bit fashionable looking. And you could actually imagine wearing this without looking like a total geek.
Yeah, even since CES, a number of manufacturers have come out with sunglass-looking headsets, and the images in these are really good, really clear, really bright, and so there is a chance that this could be adopted by consumers as a all-day wearable device.
So in VR and AR, mobile VR is going to become much more important as we get positional data all of a sudden. VR and AR are blurring into mixed reality. And AR glasses are actually striving to look reasonable in terms of fashion. The changing dynamic of that human-machine interface is going to be significant as we begin to move into these new spaces. And layered listening, where people are beginning to get control over their audio environment and the amount of ambient noise going back towards them, is going to also be significant, and a creative issue too, finally.
And within the industry, you're seeing a lot of discussion now about sound, whereas a year ago that was missing. And now we're seeing a number of conferences and panels built around spatial audio and how do you design it for the consumer experience, both in the Hollywood community and the gaming community.
And as all these things get more mobile, low latency transport is going to become very important with 5G. In the TV space, actually, while large screens were really just spectacular and HDR is beautiful, there was not a lot of excitement. And with a millennial approach being sort of the screen that's in front of me is the most important one, there's going to be a lot of competition in that space. HDR is probably the most significant thing, and perhaps actually HDR is going to be massively important when you have to compete with reality and in augmented reality, and in that space it might be even more significant, honestly. Likely the best year for large-scale displays, but again, limited buzz actually developing around them. And all of the hardware manufacturers were also showing reasons for our customers to actually have interfaces directly associated with other tasks, and so there's going to be expectations set about how one interacts. On to sensors and all of the computing that's been happening in the real world now and how it's changing. Cars are very important in this space because they're really driving the GPU development and costs. Eye tracking, computer vision, co-pilot, ambient experiences, all those things are coming out of this capability of sensors being tied to more compute capability. Let's take a look at some of those things here. The most significant thing, perhaps, was shown was NVIDIA's keynote. And there's the one thing, if you want to go look for some video about CES, look for the NVIDIA keynote video. Really spectacular. Here's an example of what's happening as their platform becomes almost ubiquitous across the car world. And we'll talk more about that in just a moment. Here we see eye tracking being developed. Watch her as she drives the car. Now we know where our eyes are. And now we'll actually begin to track where she's looking. So her actual gaze is going to be understood and what aspect of the car or control or the highway she's actually looking at. And once we've gotten to that point, this is rather amazing. Instead of listening to what she's saying, it's actually going to read her lips. The amount of compute capability in order to do that is astronomical. Here she's finally just saying, well, maybe I just need you to drive me to Starbucks and I need a coffee. That's pretty amazing. NVIDIA also showed a small box, like an Apple TV, a streamer, that's going to be focused specifically on gaming, but obviously has a TV interface associated with it. And that's significant because they can actually now put a really serious computer on your TV screen by using their new service.
Yeah, so the Shield there is going to take advantage of their new service, GeForce Now, which will allow you to move beyond these normal computers where maybe you don't want to spend all that extra coin on getting the high-end GPUs and graphics cards, but you still want access to those video games. And this service is going to be able to provide that through a very small Apple TV-like device. So we're bringing sort of that to the local TV without having too much extra peripherals around.
Here's a really significant thing. They've got a mic that you can put into an AC outlet and put multiple ones in the room and can actually localize back to that little box. So in effect, it becomes an augmented version of your whole house. It's like having Alexa everywhere, but with the power of a massive GPU behind it in terms of compute capability. So it can actually figure out where you are in the house and where you are within the room even, if you have multiples.
And so you see NVIDIA here playing in that same space that Xbox was, trying to take control of the home, but doing it in a very clever way. So this is basically a whole home retrofit for AI. And in fact, the CEO mentioned that it was bringing Jarvis to everyone's home.
Here we see Bosch, and this is really significant. They've adopted NVIDIA's platform, and so they're going to be turning out those hardened devices with plenty of security surrounding them that are going to be controlling life safety issues in your auto in the future. And the fact that this is going to happen at scale means that we're going to see the cost of GPUs coming down.
And so we see that partnership with that drive. So all of that technology that we saw with gaze tracking, head tracking, lip reading, all of that now being offered at an OEM level, which really empowers the car industry.
And here we see just an example of them doing some lane tracking. But that platform in the vehicle is going to be really significant.
Now, the way that the eyes of the car, if you will, are LiDAR, and that's what you see here, this rig from Mitsubishi. It's actually a $70,000 rig. And so you can see that that's holding back the price for a lot of these autonomous driving applications. And yet, here we have Faraday Future's FF91. And what you see there in the middle of the hood is a small Velodyne system, and that's $7,000. So now we've gone from $70,000 to $7,000. And we can imagine going down even further because Osram, who already does 70%-ish of the lighting for cars, actually introduced a different sort of LiDAR rig that's supposed to ring in under $100. And so what this is making everything more compact and more affordable. And we can see that if we're making jumps from 70,000 to 70, it won't be that long before we start getting to the 70 cents range. And as we get to that sort of price range, we can start expecting them to seep into other different types of devices. The real trick with this LiDAR system, so whenever we say LiDAR, think sonar with light. What it's doing is allowing you to get a lot of information about the world around you in a less dense way. So it's less heavy on the processor, but you still get all that beautiful information of how a person's moving or how different things are reacting inside the outside environment.
And as opposed to using lots of compute capability to figure out a z-axis and where you are with a camera, it's really efficient and almost analog-like in terms of its speed.
Absolutely. So like we mentioned, as these things become cheaper, we'll start seeing them embedded in other devices. So what we have here is Intel's Project Alloy. Right now, it uses a couple of cameras, similar to what we saw in the last section, to do merged reality. So map out the room and put things on top of those different spaces. But it's still struggling with latency, and that's all due to that compute power. We also saw some of our familiar items start taking on new uses as sensors become embedded in them. So what you have here is a Marty McFly-like shoe that has different accelerometers, temperature gauges, and things like that that's put inside it. So what it could allow you to do is imagine the compute power that you put into a VR experience where you're trying to figure out where someone's walking. If you had direct access to these sensors, now you can tell not only where they're walking, but when they might be taking a tentative or a hesitant step and translate that to the user experience. We also saw something from Xenoma that was showing more and more integration of these versatile sensors, and we saw a number of different sensor capabilities being expanded throughout CES. But as these start becoming embedded in these everyday devices, we can imagine in just a few years Under Armour really being able to map out the entire biome or the entire biological set of parameters and integrate them in a meaningful way. And that's really what we're showing here with this Oakley Radar Pace together with Intel. So what they're doing is translating all of that information through an AI coach and giving it to you in a way that's meaningful. So instead of step counts, now we can say run faster, run harder, train for that 5K in a better way. And it's really taking us to an entirely new place. So a few years ago, we saw a Panasonic mirror that was giving sort of a dashboard of your whole health and what you were going to do that day. And the question was asked, well, is this possible? Well, now we're finally starting to see the realization of IoT in a confluence with AI that's really giving meaningful data that's going to drive those experiences. And of course, all of that's dependent on being able to get that data from one location to another. And that's what Qualcomm and Ericsson were talking about this year at CES, which is their 5G network. And what we're seeing here is a demonstration that we'll get to in a moment of streaming 4K video, streaming it to a phone in real time like this. And Intel had something right next door that was showing streaming VR. So the amount of power that you would need to do to be able to do that and the amount of bandwidth that you need is awesome. And that's what we see with this device here. But it's finally beginning to get realized. So as we see this, the infrastructure be built, we'll be able to get that data up to the cloud, be able to have AI agents talk to one another and process this in a more meaningful way that gives us really something that we need at an individual coach level if we're talking about AI agents. And to that point, we had a very interesting company called Emotech show us a device called Ollie. And this was one of the big winners at CES, especially at CES Unveiled, that learns how you like to be spoke to. So imagine Alexa on steroids, but not just that. Alexa with a personality, so that it learns how you like to talk to it, and it can identify individual users, of perhaps even identify when you might have put a newspaper over your keys.
And here's an example of IoT gone crazy, if you will, a future version of it. We'll run this so that you can actually hear what they're doing. This is rather amazing from Carnival cruises.
You are going on a journey when you go on a cruise ship, but you're also going on a journey of experience and of adventure. And we wanted to create a product experience that it itself was like a journey. On the digital side, we have the compass, and on the physical side, we have the medallion. In a sense, it's like a modern-day currency. It's technically the most advanced currency you can imagine. It empowers you to get into places automatically. You can buy things with this, and it enables personalized experiences. Each medallion is personally assigned to each guest, so their profile is connected to the medallion. Just by walking up to your stateroom and opening the door and walking inside, you don't need to bring out your phone. You don't need to tap in a code.
When we started designing the compass, we wanted to make sure we designed it in a way that anyone could understand. And what everyone in the world understands is time. So the navigation on the compass is just simply left to right as it relates to a timeline. Being able to look forward and engage in experiences, it allows you to get excited. It allows you to maximize your experience because you know everything that's available for you. And then navigating up or down just allows you to navigate up into possibilities or down into detail.
So that's a rather complete IoT image across a ship, and it's sort of a special situation because you are at sea and so in international waters and cut off from some reality, and it seems possible that you could actually deal with the security issues involved. But actually, how do you actually put that massive sort of thing into a ship? And this is rather an amazing thing in that they're going to be, across the next 18 months to 2 years, putting this into 2 complete lines, about 20 ships. Ships don't come in very often. In fact, 10 days in dry dock is the total limit.
Some great teams are running roughly 75 miles of cable, installing almost 7,000 sensors, 650 XI ECDs, our Experience Edge computing device, and 4,030 additional guest portals scattered throughout the ship.
So that's an important aspect of this. And so as we talked about the cars and the importance of NVIDIA and those compute capabilities and hardened platforms, one of the capabilities that we're hoping that gets enforced at that point is real security. And we're guessing that as people want to connect with the house, that there's going to be an Apple-like connection in terms of iOS and how you buy a program from the Apple Store, with how you begin to connect security, and that things will be rated and in effect licensed into the system because of their security understandings. So that's our potential, we think, for security to get better as these systems go into the home. And here's my silly example of a familiar object actually taking on some new capabilities. It's just a clock, but it also, at times, ties to Bluetooth on your phone, which you're pulling out of your pocket 1,500 times a month, it turns out. And it actually just reflects what's happening and your schedule as you move throughout the day, and perhaps what that weather is looking like, or the fact that someone's on the phone, or that an Uber has just arrived. Familiar objects are going to take on new capabilities as they get sensors and more data into them. So takeaways from this space, new uses for familiar objects are going to be something that we're going to be dealing with constantly. Technology is going to be reaching out to us and augmenting our world in sort of wonderful ways. We'll see changing perceptions of the amount of accuracy someone's offered to us by a system, and ambient environments are going to feedback more and more, and that gets us have an opportunity for new kinds of entertainment experiences. So on to understanding our audience and how machine learning is going to influence things, and how eventually artificial intelligence will also influence things, and the ubiquity of assistance that's occurring already with Alexa all over the place. He's going to help us out by actually giving us an overview of how these things fit together.
Thanks, George. as you know, AI is one of the buzzwords of the tech and media industry these days. It certainly was at the center of the buzz at CES. I thought I would sort of give you an overview of what we saw and the limitations that we personally saw in implementing the vision that all the vendors and the CEA deployed around AI. So there's two concepts that are usually used interchangeably that are actually quite separate. It's machine learning and artificial intelligence. Machine learning seeks to build software that learns from data. Artificial intelligence seeks to build thinking machines. So you have learning machines versus thinking machines. As you can imagine, machine learning is a crucial requirement in artificial intelligence applications, but artificial intelligence actually contains a lot more elements, such as knowledge representation and reasoning and decision sciences and things like that. So the vision that CES served us this year was really the vision of ambient intelligence, everybody connected, personalized insights, behaviorally driven insights from the Internet of Things and connected devices would create this ambient intelligence that would provide value to us, anywhere and all the time. The issue with this is a lot of the applications that we saw are actually in the machine learning category, not in the artificial intelligence category, where the vision that was articulated is really an AI vision. And the difference is such that there's really a lot of limitations currently with a lot of the machine learning frameworks that we see to transition to a full AI cognitive architecture. One of them is the ability to represent knowledge from disparate sources of data. So here you have 350 million nodes in the IoT. You have all sorts of wearables and devices collecting and outputting data in their own formats and their own taxonomies. And the value there is sort of very narrow because all that data is very fragmented, is very siloed. What you really want is the ability to represent that data in a very unified manner and have a bunch of AI and machine learning plugins to be able to derive insights that are personalized, relevant, context-aware, and things like that. We haven't really seen that very much. We've seen most of the stuff that we've seen that was labeled as AI was actually machine learning. And the difference is pretty significant, right? Because machine learning needs a lot of data to train. Machine learning applications, especially deep neural networks, massive amounts of data to train. They need very specialized knowledge. If the domain of application sort of diverges even a little bit from what the training domain was, then the application fails. In an AI environment, an AI agent is able to reason from disparate data sets. And we'll see that the interesting aspect of this debate is also the fact that a lot of these technology vendors and the technology industry in general doesn't really think behaviorally, which is interesting in this context because the entertainment industry really does and does it very, very successfully. So we'll see a few examples of machine learning AI applications that run the gamut of sophistication from the sort of the most straightforward ML applications to the most advanced AI applications. And we'll see that the value is not necessarily doesn't scale in parallel with the sophistication.
So here's an example coming up that's currently in 50 hotels.
All right, so this is interesting. This is Savioke. It's a company coming out of MIT. This is a robotic room service company, and this is a classic example of something that is sort of fairly sophisticated, but it's not a full AI application that is driving a lot of value because the use case is very straightforward. it's very behaviorally driven. I mean, this definitely solves a problem in the hospitality industry. We've seen a lot of robots at CES, and again, sort of a lot of variance in terms of sophistication and value. And we'll see another one that we like that was very, very clever. This is
Wake up, Ollie.
Ladies and gentlemen, I am Ollie. Wake up, Ollie.
Hello. I'm Ollie. Your first robot with personality. This is my first time at CES.
all right. So this is a British company called Emotech that came out with this personal assistant chatbot called Ollie. And the interesting thing about Ollie is that unlike Alexa and the Google Home of the world, it personalizes the interaction that it has with the humans. And this is an interesting dimension for us, because that element of personalization and human-machine interaction is very, very important moving forward. And what Ollie does really isn't super sophisticated. It really, what it does is sort of collects ambient data on the patterns of interaction that you have with Ollie and adapts to that. It looks also for emotional tonality, and sort of Ollie will have different personalities depending on the personalities of the people who interface with it. Going back on the personal assistants and Alexa and Google Home, I mean, Alexa really was one of the most talked about systems at CES, and definitely in the run-in for owning the home. The issue there, like I was mentioning earlier in my intervention, is a lot of the skills, what Alexa calls skills that are actually applications, really, again, are very fragmented and deliver value in a very sort of siloed manner. So you'll have your weather, you'll have your traffic, you'll have your news, you'll have your sports results, but they don't have the capability to unify that data in a knowledge representation and reasoning scheme that would be closer to an AI application, a full AI application that we haven't really, everybody was talking about, we really haven't seen, that would drive a lot of value for the consumer. Now, what we're going to see next, on the other hand, is the much, much closer to an AI infrastructure.
Do you have feelings?
I can do what you do, but I can never feel human emotions as such.
But would you like to?
It doesn't sound fun to me.
Oh, no, you'd love it.
Yeah, that's right. Why so negative? You and I are on the same wavelength. Charlie.
I fear that.
We have nothing to fear but fear itself. FDR.
All right, so this is really interesting. This is Sophia, the humanoid robot by Hanson Robotics, an American company actually based in Hong Kong. Sophia is a robotic application that borrows from what we're calling artificial general intelligence. And there's two kinds of AI. There's narrow AI that can perform human actions in a very narrow domain, like a self-driving car, for example, or trading stocks. Or AGI, artificial general intelligence, is an AI application that is able to perform at or above human intelligence across the domain of applications. So, if you take a self-driving car application, you can't take that application and use it to trade stocks. An AGI application will be one AI framework that you can apply to anything, right? From driving a car to learning a language to trading stocks. And Sophia is not a fully developed AGI application, but is an application that really has a lot of AGI ambitions. The difference, and there's something that is really important about what Hanson Robotics is doing, the difference is that Sophia has at the core of it an extremely sophisticated knowledge representation and reasoning architecture that is able to take inputs from various data sets in different taxonomies and really merge it together and represent it in a very coherent way, in a very scalable way, and is able to reason from it, including in in domains that Sophia wasn't specifically trained into. And that's really the difference between sort of AI machine learning and AGI, is that AGI applications have the ability to reason from bits of data and bits of experiences that are not directly related to the domain that they're trying to apply this to, just like we as humans are able to borrow from different experiences that maybe aren't directly related to something that we're trying to figure out, but we're able to represent that. So be on the lookout for Sophia and Henson Robotics. David Henson, who's the CEO of Henson Robotics, has a big ambition around robotics. He thinks that robots should be a new platform to tell stories that are half in the digital world and half in the real world, which we think is really interesting. The first commercialized application of Henson Robotics, which was at CES, is the Einstein robot, which is a small desktop robot that looks like Einstein and comes with a bunch of iPad applications that is supposed to teach kids about science. So overall, right, to wrap up, we're seeing again the vision that CES was presenting to us, which is the vision of an AI-driven world, has sort of a few bottlenecks. One is behavioral, and the fact that a lot of the stuff that we saw that was quote-unquote intelligent or data-driven really didn't really have a lot of values to our life. And from a behavioral standpoint, if you think about, the technology might be amazing, but if nobody really can see any use for it, then it really doesn't have a lot of value. And the second bottleneck is a technical bottleneck. It really is about how do you take all of this data that comes, from millions of sources and normalize it and represent it in a way that then you have AI and machine learning plugins that are able to analyze it, learn from it, including reason from it in areas that maybe there isn't too much data or the data is very ambiguous. And AI might be able to think probabilistically about domains that it doesn't really have a direct experience in, and be on the lookout for applications that are heavy on knowledge representation and reasoning moving forward, because it really will be the key to going from a machine learning driven world, which has applications that deliver massive value, but in very, very narrow fields, such as image recognition or signal processing, to an AI, a truly AI world where we can get the insights that we need, when we need it, where we need it.
So implications for media as we move forward, given all that we saw at CES, we're sort of at the calm before the storm. VR is everywhere, but it's not yet out in standards. Pieces of the next generation experience are all over the place and scattered throughout the hall. Sensors are there without much common sense, but soon we'll organize in order to use that. Autonomous driving is about to be an important force, and an important force in terms of compute capability, which is going to affect us. They're the early signs of that AI revolution starting. Data complexity is going to be a barrier, as it is right now, but actually get worse. High-end AR was really, really beautiful. Not at the price point where consumers can afford it yet, but we have hopes in that space. And advanced audio is not a consumer object yet, but will influence many things going forward, and often creative things going forward. As that begins to be real for us, screens are going to be struggling for share. The rise of ambient sound is going to be a new thing that's going to affect many different kinds of art forms. Audio is going to be blended into the experience from the real world soon. Changing dynamics of the machine-human interface are going to be important. We're going to see lots of sensor modalities that give us much more information about the specifics of what's happening to us. The rise of mobile-based VR and AR are going to be very important as consumers can afford that piece, and the capabilities are rising. New uses of familiar objects is going to continue, mainly because of 5G. AI is going to become networked AI, and it's going to be important. Computer perception, computer vision, for instance, is going to be very important to understanding our intent and context. And Alexa is setting many new expectations for what's going to happen in the future. Implications going forward, VR is going to move into a couple of de facto standards, the room and console, and more importantly, mobile. AI is going to engulf many aspects of our business, but it's also going to give us the capability of delighting our audiences. Mobile AR will soon see lots of development since the stores are already there in place in the mobile world, and developers are going to be jumping in that space. Experiences are going to be powered by computer vision, data complexity will be an emerging obstacle in all of those spaces, and AI, and especially knowledge representation and reasoning, are going to become really important for our industry because we need to understand what's happening to people and as they have experiences. And AI is going to become a core skill within entertainment very quickly. Now for just some fun. Let's take a look at some things that we saw at CES. Top left with Hover, it actually folds up like a book, has a camera in it, can follow you anywhere you go for that perfect vacation walk on that hill town in Italy. Below, shaker chairs were last year. This year it was massage chairs all over the place. And off to the right, you see another version of a Z-axis being developed from a single camera on a smartphone. Top left, you see an incredible little drone. It's meant for camping or skiing. It actually has a real live tether connecting you to the drone, so it can really respond fast to where you're going. On the left, we saw another shaker chair showing up finally. And top right, we see a 3D-like LED display with a spinner, in effect, as it's called. And there below, on the bottom right, actually navigating a musical interface in AR. Top left, we see actually a drone war, a new game, as opposed to shooting down drones for security reasons, doing it for fun now. And these are actually hardened sort of drones. But the most interesting thing, and actually this got more interest than some of the beautiful screens at LG, was a demonstration of the fact that live theater is still going to hold on as very important, as the simplest of things can really capture our imagination. Thanks for listening, and we hope that this was helpful for all of you.